melody and place them both in mine. You know you stopped me dead while I was passing by, and now I beg to see you dance just one more time. Ooh, I see you every time.
Hello, good day everyone. Today we are going to discuss the elimination of arbitrary constants, no? And for our first slide, we have this definition of what is elimination of arbitrary constants. The number of derivatives or order to be used is the same. Take note of this one. The same as the number of arbitrary constants to be eliminated. So this will simply mean that if you have two variable, two arbitrary constants in the equation, so you need to derive the second order number of derivatives. If ever the arbitrary constants are 3, so you need to take the third order derivative of the said equation. Okay, in each case, determine the differential equation dE that is first of order equal to the number of arbitrary constants in a given relation. So normally in the problem, this relation is given through an equation, and we need to eliminate some arbitrary constants. It could be 1, 2, or more arbitrary constants depending on the nature of the problem. Number 2, consistent with that relation, with this relation relating now to the equation given. And third, free from arbitrary constants. Okay, so actually we have 3 examples for this day, and the first one will be this one. Eliminate the arbitrary constants C1 and C2 from the relation. So this equation is given y is equal now to C1 times e raised to the exponent of negative 2x plus C2 times e raised to the exponent of 3x. Okay, so here we have 2 arbitrary constants in this variable C1 and C2. So according to the definition, we need to have to get the second order derivative of this given equation y. So first and foremost, we are going to rewrite this one as our first equation. Okay, so we have y is equal now to C1 times e raised to the power of 2x plus the second term is C2 times e raised to the power of 3x. So we will denote this one as our equation number 1. Okay, so we need to get the first derivative of this one, and certainly after the first derivative we are going to get the second derivative, so that we can get the value of our equation in which free from this arbitrary constant C1 and C2. So from here, the derivative of your y d over dx of this variable y, which is just equal to dy over dx, is equal now to, we need to consider first this first term, C1 times the derivative of this e raised to the power of negative 2x. Okay, e raised to the exponent of 2x, and then After this one is this plus, again this e to the 2x to the negative 2x times the derivative of your d over dx of your c1. Okay, so after this one, so we are done with our first term. So this is one term actually, no? We're going to put this as a bracket, no? Since this one is the referring to this first term, no? The c1 times e raised to the negative 2x, and we are taking now the derivative of your y, or the dy over dx. So in terms of this first term, so this would be now the c1 times the derivative of your e to the negative 2x plus this e to the negative 2x times the derivative of your c1. So plus, you have here plus this term. So again, we will put a bracket here. So c1, c2 is rather times the derivative of your d over dx of this e to the power of 3x plus this e to the power of 3x times the derivative of your d over dx of your c2. Okay, so we have now this first derivative now, and we will simplify this one. So our dy over dx is just equal now to, first with this one, c1, we have here c1 times what is now the derivative of our e raised to the power of negative 2x. So from our previous lesson, the derivative of this one will be e to the u times the derivative of your u, where our u in this case is equal now to negative 2x. So this would be times e to the u, which is negative 2x, times the derivative of your u, where we get the derivative of your negative 2x, which is just equal now to negative 2. Okay, so we are done with this first, no? And then we proceed with the next one, plus e to the negative 2x. Actually, we have here the derivative of your constant is just equal to 0, so we can actually have this one here as equal now, this term as equal now to 0. Okay, since the derivative of a constant is 0. Okay, so proceeding with this one, so this would be now equal plus 0 bracket. Okay, so we proceed with this another term, no, referring to this c2 times a raised to the power of 3x, in which we will get now their derivatives. Okay, so this would be plus, so proceeding here, plus, so we have this c2 times the derivative of this one is e to the u du, in which our u is 3x, so this would be times e to the power of 3x times the derivative of your 3x, which is 3, and again this one is just equal to 0. Okay, since the derivative of a constant, no, of your c2 is equal to 0. Okay, so this is 0, and this would be then plus 0. So proceeding, we have now this dy over dx is equal now to this one. If we are going to simplify, this one is negative 2c1 times e raised to the negative 2x. Okay, So negative 2c1 times e raised to the power of negative 2x, and then this is just equal to 0 plus this one plus this term, which is 3c2 times e raised to the power of 3x. Okay, so this would be now our equation number 2. Okay, so we will put here equation number 2, which is equal now to this dy over dx is equal now to negative 2c1 e times e raised to the power of negative 2x plus 3c2 times e raised to the power of 3x. Okay, and this is just equivalent now to our y prime is equal now to dy over dx, which is equal now to negative 2c1 times e raised to the power of negative 2x plus 3c2 times e raised to the power of 3x. No, so this is just equivalent to your y prime. So we are using now this y prime, no, in terms of this dy over dx. So we are done with our first derivative, and since our arbitrary constants are 2, so we need to get the second order derivative. Okay, so we have now this y double prime, which is equal now to your second derivative, no, with respect to x to this one. So our constant here is negative 2c1, and our variable here is e raised to the power of negative 2x. So same for this term, no, for the second term, our constant here is 3c2, and then our variable is e raised to the power of 3x. So again, we will have now this second derivative. So first we have this negative 2c1 times the derivative of your d over dx of this term, of this variable e to the power of negative 2x, okay, plus this e to the negative 2x times the derivative of your this negative 2c1, okay, negative 2c1, okay, and this is now our first term here. So we are not done with this derivative of the second term. So proceeding with our calculation, so we have here this second term plus we put a bracket here for this one, 3c2 times the derivative of your this e raised to the 3x, okay, plus again this e to the 3x times the derivative of your 3c2, okay. So we are going to simplify now this second derivative, no, y double prime. We just simply use this y double prime, which is equal now to this negative 2c1. So we have a bracket negative 2c1 times the derivative of your e to the negative 2x is just equal now to e raised to the power of negative 2x times the derivative of your u, which is negative 2, plus this one. Actually the derivative of your negative 2c1 or the derivative of your constant is just equal to 0. So actually we can directly put this value as equal to 0. Okay, and then for this term, so this is 0 here and bracket, so plus this one 3c1. We have now this 3c2 times the derivative of this one, which is e to the 3x times the derivative of your 3x is 3. Okay, plus again for this term, it is just equal now to 0, since the derivative of a constant is 0. So your constant here is 3c2. So it is actually here plus 0. So simplifying this one, we have y double prime is just equal now to this negative 2 times negative 2 is positive 4. 4c1 times e raised to the negative 2x, and then this is 0, so we proceed with this another term plus this one. 3 times 3 is 9 c2 times e raised to the power of 3x. Okay, so we will consider this one as our equation number 3. Okay, so proceeding again, we have actually now this equation number 1, which is given by this y equals to c1 times e raised to the negative 2x plus c2 times e raised to the power of 3x. And we already have now the first derivative, which is our equation 2, and the second derivative, which is our equation number 3. So we are going to work with these three equations so that we can get the value of our equation without this arbitrary constant c1 and c2. So we have here this one. Okay, so we have now this equation 1 and 2 actually. So we have to eliminate. The eliminating the arbitrary constant c1. Okay, so how will we eliminate this arbitrary constant c1? So we are going to use the equation. We are going to use the equation 1 and 2. Okay, using equations 1 and 2. So we have now this equation 1. So we will erase this one first. Okay, so we have here our equation 1, which is y is equal to c1 times e to the power of negative 2x plus this c2 times e to the power of 3x, which is our equation 1. And for our equation 2, actually we have that equation 2, which is equal to our y prime is equal now to negative 2c1 times e raised to the negative 2x plus the second term is 3c2 times e raised to the power of 3x. Okay, so this is now our equation 2. So eliminating the arbitrary constant C1 using equations 1 and 2. So here, as you can see, they have common C1 and C2. Actually, so we first eliminate this arbitrary constant C1. So we are going to multiply. We are going to multiply equation 1 by equation 1 by 2. Okay, so that we could have this 2C1, and then we can eliminate also after we are going to add that equation. We can eliminate actually the C1. So we are going to multiply equation 1 by 2. So equation 1 will then be 2 times y. So we are going to multiply this one. We are going to erase this one first. So from here, this is now our equation 1. Y is equal now to C1 e raised to the negative 2x plus C2 times e raised to the power of 3x. So we are going to multiply this one by 2. Okay, so this will be then equal now to 2y. So 2 times y is 2y, and then 2 times this term. So this would be 2 C1 times e to the power of negative 2x plus 2 times this term. So 2 times C2 times e raised to the power of 3x. Okay, so after this one, this equation 2 remains. Okay, so our equation 2 will be y prime is equal to negative 2 C1 e raised to the power of negative 2x plus 3 C2 times e raised to the power of 3x. Okay, so actually here we can actually eliminate we can actually eliminate here our C1. So if we are going to add this 2y equals to 2c1 times e raised to the power of negative 2x plus 2 c2e to the 3x to this equation below this equation, this 2y. So actually c1 is eliminated. Okay, so proceeding with this calculation, we have this value of your equation. So 2y plus y prime. Okay, since we are going to add this one, we're going to add so that we can eliminate this c1, because 2 plus negative 2, so it's just equal now to 0. So c1 is being eliminated. So 2y plus y prime plus y prime is equal now to, this is 0. Okay, so we put this one as here equal now to 0. Okay, so this is now equal now to 0. So we have now this term only here. So this would be 0 plus this one 5. 2 plus 3 is 5 c2 times e raised to the power of 3x. Okay, or we have now this y prime plus 2y is equal now to 5 c2 times e raised to the power of 3x. Okay, so we will consider this one as our equation number 4. Okay, since we already have equation 1, 2 and 3. Okay, so after this one, we are going to eliminate the arbitrary constant C1 in equations 2 and 3. So here we have eliminating the arbitrary constant C2 using equation 2 and 3. Okay, since we are done with equations 1 and 2, so our next step is we are going to use equations 2 and 3 to eliminate the arbitrary constant C2. So here, if you can still remember the equation 3, so actually we have here this equation 1, and this is our equation 2. So y prime, okay, so let us make this one clear. So this is our equation 2. Y prime is equal now to negative 2 C1 times E to the power of negative 2x plus this 3C2 times E raised to the power of 3x. So this is now our equation 2. And our equation 3 is, if you can still remember, we have this second derivative now, which is y double prime is just equal to 4C1 times E raised to the power of negative 2x, and we have now the second term as 9C2 times E raised to the power of 3x. So if I can remember it right, so this is now our equation 2 and 3. So here we are going to multiply this y prime this equation. We are going to multiply this by 2 so that we can have now this 4, and then if we are going to add the two equations, so we can eliminate this C1. Okay, we can eliminate C1. Okay, so here this one, eliminating the arbitrary constant, this is actually C1, rather this is C1, not C2. So eliminating the arbitrary constant C2 using equations 2 and 3. Okay, so in this one we are going to eliminate the C1 from these two equations, since we already eliminated the C1 from this equation 1 and 2. Okay, so our next step will be eliminating arbitrary constant C1 using equation 2 and 3 rather. Okay, so here multiply equation 2 by 2. Okay, so after this one we can have this value. So this is times 2, so we have now this y prime equals now to negative 2 C1 times E raised to the power of negative 2x plus 3 C2 times E raised to the power of 3x. So we are going to multiply this one by 2, and then this equation below, this y double prime is still remain y double prime is equals to 4 C1 times E raised to the negative 2x plus 9 C2 times E raised to the power of 3x. Okay, after you multiply this one, so this will be 2y prime equal now to 2 times negative 2 is negative 4 c1 times e raised to the negative 2x plus 3 times 2 is 6 c2 times e to the power of 3x, and our y double prime will still remain. Okay, this is 4 c1 times e raised to the negative 2x plus this 9 c2 times e raised to the power of 3x. Okay, so if we are going to add this one, these two, so this one will c1 will be eliminated. Okay, so this could be equal now to 0. Okay, so proceeding, so we have here 2y prime plus y double prime is equal now to 9 plus 6 is 15. So this is 0, no? So this is 0 plus 15 c2 times e raised to the power of 3x, or we have now this y double prime plus 2y prime is equal now to this 15 c2 times e raised to the power of 3x, and this is our equation number 5. Okay, so now we have now this equation 4 and 5, so we are going to use these two equations to eliminate the arbitrary constant 2. Okay, so eliminating arbitrary constant c2 using equations 4 and 5. Okay, so we have now this calculation, eliminating arbitrary constant c2 using equations this 4 and 5. Okay, so here we have so we will erase this one first. No, actually we already have now this equation 4 and this 5, so we will erase this one here so that we can proceed with our calculation. Okay, so we are going to use equation 4 and 5, so our equation 4 is just equal to y double prime plus 2y prime okay, so actually we will start first with our equation 4. No, so our equation 4 is actually y prime plus 2y is just equal now to 5 c2 times e raised to the power of 3x, which is our equation 4. Okay, and this will be now our equation 5. So we have also a y double prime plus 2y prime is equal now to 15 c2 times e raised to the power of 3x. Okay, so from here you can see that in order to eliminate the variable, no, or the arbitrary constant rather c2, we are going to multiply equation 4 with equation 4 by 3. Okay, so that it could result to 15. Okay, so after this one, multiplying the equation number 4, so we have here y prime plus 2y equals to 5 c2 times e raised to the power of 3x times 3. Okay, and then this y double prime plus 2y prime is equal to 15 c2 times e raised to the power 3x. Okay, so after you multiply this one, this will be 3y prime, 3 times this one, and then 3 times 2y plus 6. Okay, 6y is equal now to 15. 3 times 5 is 15 c2 times e raised to the power of 3x, and then this one remain. Okay, so this would be y prime plus 2y prime is equal now to 15 c2 times e raised to the power of 3x. Okay, so after this one, if you are going to subtract, no, in order to eliminate this one is you are going to subtract. Okay, so that this could equal b to 0. Okay, so if you are going to subtract, this would be 3y prime plus 6y. Okay, and this would be, this is equal now to 0. Okay, okay, so this could be 3y prime plus 6y, then you minus this one with this y double prime plus 2y prime. Okay, okay, which is then equal now to 0, since the difference of this one is 0. Okay, so we have simplifying this one, so 3y prime plus 6y minus y double prime, negative 1 times y double prime, so negative 1 times 2, so this would be minus 2y prime. Okay, is equal now to 0. So simplifying this one, we have here 3y prime and this negative 2y prime, so this would be equal now to 3 minus 2 is y prime. Okay, y prime plus 6y minus y double prime is equal now to 0. Okay, so making use of the sign of this second derivative to be positive, no? So if we are going to transpose to the other side, so this will just equal now to y double prime. So here to the other side is, this could become positive, and this would become, this y prime would become negative y prime, and then transposing to the other side, minus 6y is equal now to 0. Okay, so this is it, no, for this problem, in which we already eliminated the arbitrary constants, rather c1 and c2, from this relation, no, which is given y is equal now to c1 e raised to the power of negative 2x plus c2 times e raised to the power of 3x. So probably this is now your answer. Okay, so as a gist for this one, actually for this case, no, for this problem, this relation y is given, no, so you take this one as your equation 1. Okay, so after getting the equation 1, so you get now the first derivative of this one and take that one as equation 2. Okay, and then after you take that one as equation 2, where this is now the first derivative, you take the second derivative as equation 3. Okay, and then after that one, you have equations 1, 2, and 3. So you are going to eliminate the arbitrary constants, no? First, you are going to eliminate the arbitrary constant c1, and then after that You are working with equation 1 and 2 with that, and for eliminating also the arbitrary constant C1 for equations 2 and 3, you can eliminate that one, and after you are going to use the equations 4 and 5 to eliminate the arbitrary constant 2. So okay, so as a step for this one, first you are going to set the relation which is given in this problem. Set the relation which is given in this problem as your equation 1. Okay, so after that one, get the first derivative of equation 1. Okay, and after getting the first derivative, and set it as equation 2. Okay, so after that one, get the second derivative. Okay, so you are going to get the second derivative actually of your this one. Get the second derivative of equation 1, and you set it as your equation number 3. Okay, okay, so after that one, you're going to number 4 step is, so you have now the 3 equations, so you work with equations 1 and 2. Work with equations 1 and equation 2 to eliminate the arbitrary constant, where in this case C1. Okay, you are going to work with equations 1 and 2 actually, to eliminate first the arbitrary constant, and then afterwards your fifth step will be work with equations 2 and 3 to eliminate the arbitrary constant C1 also. Okay, arbitrary constant. Okay, so to make this clear, this is arbitrary constant C1. Okay, so after eliminating the arbitrary constant C1 from equation 1 and 2, and then subsequently 2 and 3, so you are going to eliminate the arbitrary constant C2 from the equations, equations obtained from the equations obtained from this, from steps 4, steps 4, and this steps 5. Okay, step 5 rather. So eliminate the arbitrary constant C2 from the equations obtained from steps 4, So actually, after eliminating this arbitrary constant C1, you have an equation here, in terms of C2. And then after working with equations 2 and 3, so you are going to eliminate again their arbitrary constant C1. So you have an equations here in terms of C2. So the equations produced in steps 4 and 5 are with arbitrary constant C2. So after that one, you are going to eliminate the arbitrary constant C2 from the equations obtained from steps 1 and 4. Steps 4 and 5 rather. And after that, you have now the solution. You get now the solution of the given differential equation, which is free from arbitrary constants, okay. So this would be it, for this one, for the steps, that we have for this problem. I hope you will remember this one, so that given the same problem, maybe with different variables, maybe you can solve the problem more or less using and following the steps. Okay, so proceeding, raised to the squared plus y squared is equal now to a squared. Okay, so with this problem, actually we can actually differentiate this one. Our approach here is we are going to differentiate explicitly with respect to variable y, or with respect to y. Okay, so that would be our approach here, from the given relation, with this equation. We are going to differentiate explicitly with respect to y. Okay, since our derivative, so we are going to determine the derivative of y now. And actually I can present to you here two solution. We just concentrate first with our first method or solution, and later after the first method, I will give you an alternate solution on solving this given relation x minus a raised to the squared plus y squared is equals to a squared, in which we are going to eliminate the arbitrary constant a. So proceeding, so how will we differentiate this one explicitly with respect now to y? Okay, so first we have here, so we take now the derivative actually. So the derivative of this term, and then the derivative of this term again, and then the derivative of your a, in which in this problem a is constant. So proceeding with this, we have now this derivative of your, we take now the derivative of your x minus a squared plus the derivative of your y squared, and then we have now the derivative of your a squared. Okay, So from here we can get now this derivative, which is equal now to 2 times x minus a, and then this one is from your calculus, this would be 2 minus 1, okay, and then plus the derivative of your y, no, y squared is 2 times y, then this would be 2 minus 1. Since we differentiate explicitly now with respect to y, so this would be the derivative of your y, which is y prime, okay, which is then equal now to the derivative of a, which is constant, is just equal now to 0, okay. So I hope you can still remember your calculus, no, with regards to differentiation. Okay, so we have here, actually, if you can still recall, no, from your differential equation, the derivative of your x to the n is just equal now to n times x times n minus. Okay, so from here, this would be 2 times x minus a. This is just equal now to 1 plus this 2y y prime is equal now to 0, okay. So simplifying, so we distribute this one, so we have this 2x minus 2a plus 2y y prime is equal now to 0. So actually these two, no, will just we can actually move this one out, no, and this would be equal now to x minus 2a, no, rather at x, this would be equal now to x minus a plus y prime is equal now to 0, okay. So after that we are going to get now the value of your a, actually. So from here we can have this value of your a, which is equal now to, so you transpose a to the other side, so that would be positive, no, a is just equal now to x plus y times y prime, okay. So this would be now our value of our a. So you're going to substitute now this a, no, to this given relation, no, x minus a raised to the square plus y squared is equal now to a squared. Actually, as what I've told you, we will consider this given relation as your equation 1. So here you can say that substitute your a to the given relation, which is our equation 1, okay. So actually we have it here as x minus a quantity raised to the power of 2 plus y squared is equal now to a squared. So we are going to substitute a here, so this would become x minus, our a is x plus y prime, then raised to the power of 2 plus this y squared is equal now to, our a now is this one, so x plus y prime raised to the power of 2, okay. So if we're going to simplify this one, so we can distribute actually this negative sign here, no, in its term, so this would become x negative 1 times this x is minus x negative 1 times this y prime rather. So we have this minus y prime, okay, raised to the power of 2 plus this y squared is equal now to x plus y prime raised to the power of 2, okay. So this one actually is, this will cancel out, okay, x minus x. So this would become now minus negative y prime raised to the power of 2 plus y prime just equal now to x plus y prime raised to the exponent of 2, okay. So proceeding, we have now this one as negative 1 raised to the 2 is just positive, so this would become the y squared times y prime squared, okay, plus your y squared is equal now to x plus y prime quantity raised to the power of 2, okay. So now we are going to simplify now this term, no. So proceeding with our calculation, we have this y squared y prime squared plus y squared is equal now to, this is a quadratic, no, quadratic equation, so this would be equal now to x squared plus the product of this x and this y prime is, we just multiply that one by 2, no, to 2x y prime, okay, plus this y prime raised to the 2, so this would be equal now to y squared y prime squared, okay. So as you can notice, you can see it here that this term, no, will just cancel out, okay. This will just cancel out from each other, okay, because if we are going to transpose this one, so y squared y prime squared minus this one is just equal to 0, so the remaining terms will be y squared is just equal now to x squared plus 2x y prime, okay. So simplifying here, we have this, we are going to transpose this one y squared rather to the other side, no? So we have here x squared minus y squared plus 2x y prime, which is equal then now to 0. But take note, our y prime is just equal now to dy over dx, okay. So we have now this equation to be x squared minus y squared plus 2xy times dy over dx is equal now to 0, okay. So if we are going to simplify this one again, this is just equivalent to x squared dx minus y squared dx plus 2xy dy, okay, is equal now to 0. So this is just equivalent to this equation. And simplifying further, as you can notice, no, this dx is very common to x squared and y squared, so we can make it into this x squared minus y squared quantity dx plus 2xy dy is equal now to 0, okay. So this would be now our final solution for this given problem, which is x squared minus y squared dx plus 2xy dy equal now to 0. Okay. Actually, now I'm going to show you an alternate solution for this one. Arriving at the same answer with this x squared minus y squared quantity dx plus 2xy dy equal to 0. So I will show you here the alternate solution for this problem. Okay. So here we have the given relation. Okay. So from the given relation here, as our alternate solution, so we have this alternate solution. Okay, or alternate method rather. We will use the word method since this is also a solution. Okay, so from here we have from the original equation of relation x minus a raised now to the squared plus your y squared is equal now to a squared. Okay, from here we just have to go with this quadratic, no? So this would be equal now to x squared minus 2ex plus a squared, okay, plus your y squared is equal now to a squared. So as you can notice, these two will just cancel it out now with each other. So a squared minus a squared is just equal to 0. So this would become x squared minus 2ex plus y squared is equal now to 0. Okay, so simplifying once more, we have now this x squared plus y squared is equal now to 2ex. Okay, when we transpose this negative 2ex now to the other side. Okay, so x squared plus y squared is equal now to 2ex. Okay, where our 2a then is just equal now to this x squared plus y squared all over the x. Okay, so we are going to differentiate in terms of or with respect to of your y. Okay, or with respect now to y. So from here, as you can remember from our calculus, if you are going to have the derivative of your u over b, this is just equal now to b du minus u db all over your b squared. So we can apply this one, this derivatives of your u over b, which is just equal now to this b times the derivative of your u minus u times the derivative of your b all over the b squared. Okay, so from here we can use this one. So this would be equal now to the derivative of your 2a is just equal now to the derivative of your x squared plus y squared all over your x. Okay, so this is just a constant actually, since from your problem arbitrary constant a, so this is just equal now to 0. Okay, so this would be 0 is equal now to using this one, so this will be your b du. So your b here is your x, so x times the derivative of your du. Your u is this x squared plus y squared, okay, minus u, minus, where's your u? Here is your x squared plus y squared rather, okay. So u db, so from here your u is x squared plus y squared, okay, x squared plus y squared, and then derivative of your b, in which in this case your b is the derivative of your x, okay, all over the b squared, so in this case x squared, okay. So this would be equal now to 0. Then we have here x times the derivative of this one. Since we are differentiating this explicitly in terms of y, actually this is explicit, no? Explicit. Okay, explicitly in terms of or with respect to y. So this would be x times the derivative of your x squared plus y squared is, for this one you have 2x 2 minus 1, okay, plus this 2y 2 minus 1, since explicitly in terms of y, so this would be y prime, okay. And then we have now this minus, I will just to make it smaller, no, this one x squared, this one is here x squared, okay, minus this one is x squared plus y squared, okay, quantity times the derivative of your x is just simply equal now to 1, okay, all over your x squared, okay. So proceeding with this one, we have here then the value of x, so this would be 2x plus 2y y prime, okay, minus your quantity x squared plus y squared, okay, all over your x squared. So if we are going to cross multiply, so this will be then equal now to your x 2x plus 2y y prime minus quantity x squared plus y squared is equal now to 0, okay. So we distribute this one, no, to each term of this 2x plus 2y y prime, so this would become now 2x times 2x is 2x squared plus this one 2x y y prime minus, so we are going to distribute this one, so minus x squared minus this one y squared is equal now to 0, okay. So this would become 2x squared minus x squared is just equal now to x squared plus 2xy y prime minus y squared is just equal to 0, okay. So we have then this x squared minus y squared plus 2xy y prime is equal now to 0, okay. So proceeding with this one, we have then this value of, since our y prime is just equal now to dy over dx, so we have then this x squared minus y squared plus 2xy dy over dx is equal now to 0, or simply we can say that this would be equal now to x squared minus y squared, okay, dx plus 2xy dy is equal now to 0, which is still the same answer, no, with our first method, no, as shown in our previous discussion. So x squared minus y squared quantity dx plus 2xy dy is equal now to 0. So we still arrive at the same answer, no, or solution, though we are presenting, and I'm presenting to you the two methods of solving and eliminating this arbitrary constant a from the given equation or relation. Okay. Okay, so proceeding with our next and last problem. So we have now this next slide, no? So proceeding with this one, the last problem will be this one. So eliminate the arbitrary constants alpha and beta from the relation. So we have this given, no, relation or equation x is equal now to this beta cosine omega t plus alpha. So where your omega is a parameter not to be eliminated, so we are just after with this beta and this alpha, no. So actually we need to have two second order derivative, no, because of these two arbitrary constants. So we take the first derivative as this is very similar to our first problem, no, problem 1 or illustrative problem 1. So take the first derivative and then we take the second derivative, or we can solve this in any way around. So we just stick now to this very basic steps, no, in solving this one. We just get the first derivative first and then the second derivative, and afterwards we can also substitute and arrive to the solution or answer without these arbitrary constants alpha and beta. Okay. We have here now this derivative of your x d over dt of your x is just equal now to this beta times the derivative of this cosine, and then plus this cosine times the derivative of your beta. Take note, our denominator here is dt because we are now with respect now to t, no, as in variable t here. So the only arbitrary constants are this alpha and this beta, where our omega is a parameter which is not to be eliminated, no, only this beta and this alpha. So that is why with respect now with this t, because of this. Okay, so the derivative with respect to t of your x is just equal now to your beta, okay, times the derivative with respect to t of your cosine of omega t plus alpha, okay, and this would be plus this again, the cosine of your omega t plus alpha times the derivative with respect to t of your beta. Okay, so in this case, since b is an arbitrary constant, your beta, or this is an arbitrary constant, so we can say that this is just equal now to 0. Okay, so your dx over dt is just equal now to beta times, we have now the derivative of your cosine, which is just equal now to the negative sign. Okay, so this is also from your calculus. Okay, so this would be now equal now to negative sine of this omega t plus alpha, omega t plus alpha times the derivative of your omega t plus alpha. Okay, the derivative of this one. Okay, so since this alpha is variable, so we are only up to here, omega t. So this is times the omega. Okay, and then we have now this plus, this is 0, so this is just equal now to 0. 0 times the cosine is just equal to 0. So therefore, our derivative of x with respect now to t is just equal then to, if we are going to simplify this one, so we have negative omega times your beta times this sine of your omega t plus your alpha. Okay, so this is it, our first derivative, or we can just say this is just equal now to x prime, since this is x. Okay, but if this is y, so it is y prime, but this time it is x, since the given is x as a function of this beta cosine of omega t plus alpha. So this would be now our x prime equal now to negative omega beta sine of your omega t plus your alpha. So as what I've said, we consider this one as our equation 1, and this would be now our equation 2. Okay, so this would be our equation 1. Okay, so now we are going to get the equation 3, which we are going to determine the second derivative. Okay, so proceeding, we are going to determine the second derivative. Okay, since our arbitrary constants are alpha and beta, so we have to take the first and second derivative. So we have now this second derivative with respect now to time, which is just equal now to our x double prime. Okay, x double prime, which is this one, our negative omega beta times the derivative of this one. Okay, negative omega beta times the derivative with respect now to time of the quantity sine of omega t plus alpha. Okay, and then plus our sine of this one times the derivative of negative omega beta. Okay, so we are going to have that one here. So your sine of omega t plus alpha, so this again a bracket, times the derivative with respect to time of your this negative omega beta. Okay, so proceeding, so we have here our we will use now this x double prime. Okay, so we have here our second derivative x double prime is just equal to negative omega beta times the derivative of your sine. What is the derivative of your sine? Is just equal now to its cosine of the quantity omega t plus alpha times this one. Here the alpha is constant, so therefore the derivative of omega t is just equal now to omega. Okay, plus this one is just constant, no? So beta is constant, so the derivative of a constant, also this omega, no, is just a constant. Okay, so this is just equal now to 0. Okay, so this is also 0. So our second derivative x double prime is just equal now to the negative omega squared beta times the cosine of the quantity omega t plus your alpha. Okay, so this would be now our equation number 3. Okay, so based on our discussion, no, from the very first problem, next step is just we are going to eliminate, no, some variables or constant. In this case, no, actually our constant is just an alpha and beta, but still we can apply that procedure, no, using equation 1 and 2 first. So after the equation 1 and 2, we use equation 2 and 3, and after that we will work on the equation 4 and 5, which is from the step number 3 and step number 2. Okay, so we will write this one first, no, before we erase this one. So this is our equation 1, and for our equation 2 is simply as this x prime is just equal now to negative omega beta sine of quantity omega t plus your alpha, which is now our equation 2. Okay, so we will erase this one, this portion, and then we will proceed with our calculation rather. Alright, so here we are going to working with equations 1 and 2. Okay, so this is our equation 1, in which we will use x is just equal now to beta cosine of omega t plus your alpha, and our equation 2 is just this x prime. Okay, it's just equal to negative omega times beta sine of the quantity omega t plus your alpha. Okay, so we have to work with equations 1 and 2. Okay, so after this one we are going to take a difference here, so we try to take a difference here, no? Okay, so if we are going to take a difference here, so x minus x prime is just x minus x prime is just equal now to this term minus this term below. Okay, so beta cosine of your omega t plus alpha minus, okay, minus this one, negative omega beta sine of your omega t plus your alpha. Okay, so bracket, so our x minus x prime is just equal now to beta cosine of your omega t plus your alpha. Then we have here plus, okay, your omega beta sine of your quantity omega t plus your alpha. Okay, so we can denote this one as your equation 4. Okay, so now we are working with equations 2 and 3. Okay, so we have now this equation 3 here. Okay, so we will partially erase this one of this portion. Okay, so we will write first the equation 2 here, which is x prime equals to negative omega beta sine of your omega t plus your alpha. Okay, and your equation 3 is just x double prime equals to negative omega squared beta times the cosine of the quantity omega t plus your alpha. Okay, so from here again we will take a difference from these two, actually from these two equation again, from 2 and 3. Okay, so here we have minus, so we have here x prime minus x double prime is just equal now to this one, negative omega beta sine of your omega t plus alpha. Minus the negative, minus and negative is just equal now to positive. Okay, plus omega squared beta cosine of omega t plus your alpha. Okay, so we have now our, we will denote this one again as our equation number 5. Okay, from equation 2 and 3. So this time we will denote this one our equation number 5. Okay, so now we are working with equations 4 and 5. Okay, so from here we can have this x minus x prime is equal now to beta cosine of your omega t plus your alpha plus your omega beta sine of your quantity omega t plus alpha, which is now our equation 4, and our equation 5 is x prime minus x double prime, which is equal now to this negative omega beta sine of your omega t plus alpha. Okay, plus this one omega squared beta cosine of the quantity omega t plus your alpha. Okay, so after this one we are going to eliminate, no? Here if we are going to sum up this one, so this x prime will be eliminated, no? So if you are going to sum up equations 4 and 5, so x plus this would be x plus this x prime, no, negative x prime plus x prime is just 0, so will remain only the x minus x double prime. Okay, and as you can observe here we have a common terms here, no, this negative omega beta sine of omega t plus alpha, and this one Okay, so this will just cancel out, no? Okay, this will just cancel out. So we have only this beta cosine of omega t plus your alpha plus your omega squared beta cosine of your omega t plus alpha. Okay, so we are almost there, no, in the solution of this problem. So proceeding with our calculation, we have here. Okay, so from here we have x minus x double prime is equal now to, we are going to simplify, no? So we have actually a common term here, the beta cosine of your omega t plus alpha. Okay, so we can move this one out here. So we have beta cosine of your omega t plus your alpha times quantity 1 plus your omega squared. Okay, this one. Okay, so we have moved out, no, this quantity, but we have to take note that this beta cosine of omega t plus alpha is just equal now to x. Okay, take note that x is just equal now to beta cosine of your omega t plus alpha. Okay, so if we are going to substitute here, so it will be x minus x double prime equals now to x times 1 plus omega squared, in which if we are going to distribute this one, so x times 1 is x plus omega squared x. Okay, so we have here x minus x double prime is equal now to this x plus omega squared x. So this will just cancel each other, no? X minus x is equal to 0, or negative x double prime is just equal now to omega squared x, or this is just equivalent to x double prime plus omega squared x is equal to 0. Since our second derivative is just equal to our squared, no? Second derivative of x with respect to t plus our omega squared x is equal now to 0. So therefore we can say that this is now the solution to our problem, no? This x double prime is just equal now to, or equivalent to, the second derivative of x with respect to t plus the omega squared x is equal now to 0. Okay, so I think it's very clear already, no, on how to get now the solution, eliminating the arbitrary constant to different given relation or equations. But in this case, I will show you one method, no. Aside from this one, we still arrive with the same answer, no, solution with this equation, no, the second derivative of x with respect to t plus omega squared x is equal to 0. So this is a very short method, and before we end, I'll just show you, no, that method, and we try to erase this one, this portion here. Okay, so if you can still remember, no, so we have here our equation 1. Okay, this is our equation 1, and also we already get our x prime, no, which is equal now to negative omega beta sine of your omega t plus your alpha. Okay, this is now actually our equation 2, no, from the previous calculation, and our equation 3 is our second derivative, which is equal now to negative of your omega squared times beta times this cosine of your omega t plus your alpha. So we have already these three equations, no, in our previous discussion. From here, you can directly go now to the solution, no, since we already get now this equation 3. As you can observe, this one, this part of this equation 3, no, this one, your beta, which is just equal now to this x, actually beta cosine omega t plus alpha. This is just equal to x actually. Okay, so from here you can directly calculate, no. So we have negative omega squared times, you substitute the x, or negative omega squared x. So if you're going to transpose to the other side, so x double prime is just equal now to x double prime plus, this is plus since you are going to transpose this one to the other side, so plus omega squared x, which is equal now to 0 and is equivalent to our solution, okay, which is the second derivative of x with respect now to t plus your omega squared x is equal now to 0, which is still the same with our solution. Okay, as you can see it here, it is still the same as. So thank you very much for watching and listening for this lecture number 2 regarding the differential equations, and God bless us all.